What we're going to do in this network is Cambridge's version of a forward and backward scan. And what we're attempting to do is identify the critical path as well as the earliest and latest start time of all of the tasks that are on this or in this project. Alright, first things first, I like to establish all of the instances where I've got multiple tasks leading into a vertice. Got multiple tasks leading into this vertice, multiple tasks leading into this vertice, only one, only one, only one, multiple tasks, and finally multiple tasks. Alright, next order of business is to look at each vertice and establish the number of tasks coming out of that vertice. This one has 2, task A and task B. And each of those tasks get a box where we're going to write the earliest and latest start time of those tasks. So D and C, E and F, G and K, J, H, I, finish, and L. Alright, now what we're going to do is swap color and run a forward scan. Alright, earlier start time of A and B, because they can kick off concurrently and there's no predecessors, it's going to be none or 0 and 0. Alright, now let's have a look at D and C. Well, they've got task dependency on A. A takes 10, so if the earliest start time is 0, D and C, the earliest they're going to get going is 0 plus 10, which is 10. Now let's have a look at E and F. E and F have task dependency on C as well as B. So we've got to be careful here in what we write as the earliest start time, because we've got to check what's happening with A and C and B. Now, A and C, or C in this case, will be 10 plus 3. We're going to get a potential earlier start time of 13, or we're going to get a potential earlier start time of 12 from B, because 0 plus 12 is 12. Now the rule is that we put the largest number in the box. Now why is that? Because E and F have task dependency on C and B. Now C is going to take 10 plus 3, 13 to start. B takes 12. So we've got to wait for the longest task till we can begin these two, so it'll be 13 in the box. Right, down here, you notice here that there's no highlight on this vertice leading into this vertice. So that means it's a simple situation. We're going to go earliest start time of F, which is 13. 13 plus 7 is 20. 20 is going to go into both of those. Now it's the same up the top here. What we're going to do is the earliest start time of H and I will be D 10 plus 8, which is 18. So both of them get an 18. Now it certainly won't be a simple scenario for J, because J has 3 edges or 3 tasks leading into it. So it's potentially 18 plus 7, which is 25 from I. It also could be 13 plus 13, which is 26 from E. Or it could be 20 plus 5, which is 25 from G. Now, largest number goes into the box. Down here, we've got 2 edges leading into this vertice here. We've got J, potentially 36, and K, potentially 20 plus 12, which is 32. Largest number in the box. Alright, down here at the finish, we've got either 36 plus 4, 40 from L, or 18 plus 13, which is 31 from H, largest number in the box. Alright, so this project here should take 30 units of time to complete. Let's work out the latest start time of each of the tasks. Alright, the LST of the finish will of course be 40. Now let's go and back scan. Now the way we get the LST of L is to look at the previous task or tasks and establish what the lowest LST is of those particular tasks. Now in this case there's only one task, it's the finish. 40 take away 4 is 36. Over here we've got 40 take away 13 is 27. Alright, let's do J. J will be 36 take away 10, 26. Let's do K. K will be 36 take away 12, 26, 24. Alright, let's do I. I will be 26 take away 7, 19. Let's do D. D will be either 27 take away 8 or 19 take away 8. Now what we do on a back scan is we always take the lowest number if there's 2 potential or 3 or 4 potential options, however many options. So 19 is the lowest number. 19 take away 8 will be 11 for D. Alright, let's go over to E. E will be, that's a simple scenario, 26 take away 13, only one option, 13. Let's do G. G will be, again, simple scenario, 26 take away 5, 21. Let's do F. F has 2 options. Alright, so you can see here that either it's 21 take away 7 or it's 24 take away 7. And again, what we do is we use the smallest number when this situation arises. 21 take away 7, that one will be 14. Alright, now down to C. C again is that situation where I've got either 13 take away 3 or 14 take away 3. C will be 13 take away 3 because we use the smallest number. 13 take away 3 is 10. Alright, over to here we've got either 11 take away 10 or 10 take away 10. Which one are we going to use? Smallest number. 10 take away 10, 0. Alright, now with B we've got 13 take away 12 or 14 take away 12. Again, it's the smallest number. 13 take away 12, 1. Alright, and that is the conclusion of the forward and backward scan. Now, what does this tell us? Well, let's get the critical path. Now, to get the critical path, what I do is I look at tasks that have the same earliest and latest start time. How do I know? Well, let's look at this one here. A is 0 and 0, same earliest and latest start time. So I know that A is on the critical path. So let's highlight that particular edge. Alright, C is one of those situations as well, 10 and 10. So there's task C, so let's highlight that. E also is that situation, 13 and 13, so let's highlight E. J is also one of those situations, 26 and 26. And notice what's happening here. It's identifying the longest path through the project. And finally, L is one of those situations. And there it is. So, our critical path is A, E, J, and L. And what should happen is if I add those numbers together, or the task duration of those particular tasks, it should equal 40. Let's make sure. 10 and 3 is 13, 26, 36, 40. Alright, so it all works there, and we have identified the critical path, and the minimum completion time of the project is also 40.